exercise is going to get you some practice on finding 5-number summaries, standard deviations, and then talking about when to use what and which is the best measure to describe. So here's for the first data set when they were all 9s. I made the bar graph. It's kind of a they say histogram, but these are really kind of bar graphs because these are discrete data sets, discrete numbers. So I got a single bar. And if I want to talk about the 5-number summary, because that's the next thing that they want us to do, is these are all the same. So that means the minimum value is 9, the lower quartile is 9, the median is also 9, and the upper quartile is also 9, and the maximum is also 9, because those are the numbers that make up the 5-number summary. If I were going to do a box plot for that, I would just have to put a dot. I did just put on the bar because if it's space I could put it up there. So it's just a single dot because those are all the same value. Now for the standard deviation, what you need to do for the standard deviation, I mean there's certainly a ton of software out there that will calculate standard deviation for you. 6, 7. Do I have 7 9s? 1, 2, 3, 4, 5, 6, 7. What you do is, if you're going to do this by hand, you got to show the work by hand. I would set yourself up a table. Then I'm going to subtract the mean from each of these values, and since the mean is 9, 9 minus 9 is 0 in every case. And then the next part of this calculation is to square those differences. And of course, for this problem, every 0 squared will be 0. Then you're going to find the sum of all those square differences. That's what the formula says. In this case, it'll be 0 divided by n minus 1. Well, since there's 7 numbers, I'm going to divide by 6. So 0 divided by 6 is going to be 0. And then, of course, we're going to take the square root. Well, that's still 0. And, of course, we knew this was going to be 0 because there's no variation in these numbers. Okay, so that's the standard deviation. Then we're supposed to, based on our results, briefly explain how the standard deviation provides a useful single number summary of the variation in these data sets. Well, what's going to come out is these are all symmetric data sets. And we should be using the mean and standard deviation to discuss symmetric data sets. So the reason the standard deviation being 0 is useful because that tells me there's no variation in the numbers. Whereas the 5-number summary, I don't know. I don't think that's so useful here because, I mean, they're all the same number. I think if you were to tell somebody that I had a data set with a standard deviation is 0, that means all the numbers are the same. In fact, I'm going to ask you that on a quiz at some point. So for the next data set, it looks like a symmetric distribution. Again, I got a peak in the middle and 2 tails or wings off to each side. And so when I'm looking at this set of numbers, I got to find the 5-number summary. So I know the minimum is going to be 8. And I'm going to write down Q1. Median is going to be the middle number. While there's 7 numbers, the middle number will be 9. Then upper quartile we'll find in a minute, and then the maximum is 10. So now we just got to find the 2 quartiles. Well, the quartiles cut the bottom half in half. It's the median of the bottom's half a number, so that's going to be 8. And same thing for the upper one. It cuts the top half in half, so that's 10. You don't want to count the median when you're finding the quartiles, okay? That's already been used. If it's in between 2 numbers, like you have an even number data set, then it's in between. And we'll do some of those later. So here's the 5-number summary. If I want to do a box plot of this here, so I'm going to put a dot at 8. I'm going to put another dot at 8, which doesn't matter. I'm going to put a dot at 9. I'm going to put another dot at 10. And let's see, since I don't have any tails, I'm just going to There, because the lower quartile, the lower quartile and the minimum are the same, and the upper quartile and the maximum are the same, so I don't have any tails in this box and whisker plot. So, again, symmetric. Now they want us to find the standard deviation on this. So they told us the mean was 9. So 8 minus 9 is -1, and another -1, and then 9 minus 9 is 0, and again. 10 minus 9 is 1, and again. Now if we added up that column of numbers, we'd get 0, and that will always happen when if you were just to subtract a mean from a set of numbers. Okay, so now to make it more useful, they want us to square each of these differences. So -1 times -1 is 1. If you're using a calculator, you don't want to type in -1, then hit the x squared button, because most calculators will give you -1. So what it's doing is it's treating this as -1 times 1. It does in order of operations. Some of the less expensive calculators will do this. It'll give you the right answer, but that's because they just aren't as smart. Okay, so just a forewarning. Sometimes it's better not to use a calculator for the easy numbers. So same thing. I'm going to keep squaring these numbers. Fortunately, this is all easy math. Now I'm going to add them up. I'm going to have the sum of that. So I'm getting a sum of 4. So if you think about that formula, I'm taking the sum of all the x minus x bars squared. I'm dividing by n minus 1, and then I'm taking the square root of that. So I've got a sum of 4. I have 7 numbers, so 7 minus 1 is 6. And then I take the square root of that. So the square root of 2/3, you can crunch that on a calculator. I got 0.816. Okay, again, this is a symmetric distribution. Shows me, the standard deviation, the mean is the way to describe it. Another symmetric distribution, granted it's a weird one, but it is symmetric. There's a dividing line, and it's a mirror image of each other, right? So that's symmetric. So let's find the 5-number summary. I'm seeing a min of 8. I'm seeing a max of 10. I'm seeing a middle number of 9. And then the lower quartile is going to be 8 again. And the upper quartile is going to be 10 again. And this is going to have a center. Let's see. So we've got a dot at 8. We've got another dot at 9, another dot at 10. And because the max and the min are the same as the two quartiles, no tails on this one again. So symmetric. So now let's do the standard deviation. So again, they told me the mean was 9, so -1, -1, -1, 0, 1, 1, 1. And I'm going to square each of those. So that's, I write 2. You didn't see me do that. Guess the doc will let me undo it. So 1, 1, 1, 0, 1, 1, 1. Then I'm going to find the sum of those, which is 6. So 6 over, and there's 7 numbers, so 7 minus 1 is 6. And when we take the square root of that, well, that one's not too bad to calculate, because the square root of 1 is 1. So that's the standard deviation. So, and notice, this standard deviation is 1, and the other standard deviation for the one we read before this was like, what, 0.83? And the difference is, if you look at the graphs, for the other one it was kind of, well, they call it mound shape. That had a standard deviation of 0.83, if I remember correctly. And this graph had a graph like this, symmetric, but not as a little more spread out. And that had a bigger standard deviation. So the standard deviation is a measure of the spread. This one had more spread than the previous one did, and that's why it has a larger standard deviation. Okay, the less mound shape and symmetric a distribution is, the bigger the standard deviation is going to be. And that's one reason why we don't want to use a standard deviation when we have a really skewed distribution, because the standard deviation is going to be huge. It's not going to be very useful the way to describe like where is the data clustered and all that. Okay, that's why we use 5-number summaries with skewed distributions. So another symmetric distribution, much more spread out, I'd like you to think about, is the standard deviation for this distribution going to be larger than the previous couple? And, you should certainly just keep playing this if you want, but once you stop and think about it and make a prediction, whether you think it's going to be bigger or smaller than 1 or 0.83 or whatever. Okay? So let's do the 5-number summary. So I'm seeing a minimum of 6, I'm seeing a maximum of 12, I'm seeing a middle number of 9, and again, the 6 is the lower quartile and 12 is the upper quartile. So we're just going to have a box with a line in the middle of it again for our box plot. So 9, 12, 6, no tails. It's certainly possible to have a symmetric distribution with tails. It's just that these data sets aren't giving those to us. So let's see if I have enough room to do that calculation with the standard deviation right here. I think so. So there's x, here's x minus the mean, and here's the x minus the mean squared. So the mean's 9. So -3, -3, -3, 0, 3, 3, 3. I'm going to square each of those, so 9, 9, 9, 0, another 9, another 9, another 9, and let's see, I've got 6 9s, so I believe that's 54. So to get the standard deviation, I'm going to take 54 divided by 7. 7 minus 1 is 6. And take the square root of that. And if you give me a second, I actually know that's 9, isn't it? And the square root of 9 is 3. So, bigger standard deviation. A little more varied data set. Still symmetric, but just more varied. Okay? So I hope this helps you understand how to find a standard deviation by hand. 5-number summary is certainly useful, although it's not that complicated for these. And then the idea between when do you use a mean standard deviation to describe a data set and versus 5-number summary. And the other aspect is the more spread out the data, the bigger the standard deviation is. So give a yell if you need some more help.